Dear students, in JEE 2024 Phase 1, this numerical value type question was from chapter Electromagnetic Induction. The question is, a small square loop of wire of side L is placed inside a large square loop of wire of side capital L, where capital L that is equal to small l square. The loops are coplanar and their centers coincide. The value of the mutual inductance of the system is root x into 10 raised to minus 7 Henry, where x equal to what? Now see here, two square loops are placed coplanar, a small square loop with side small l that is placed at the center of the large square loop of side capital L. And now we have to find the mutual inductance of the system. Now see here, mutual inductance of the system that is given by M equal to 5 upon I. Flux associated with one loop, here we will consider the flux associated with smaller loop, and I that is the current flowing through other loop. So here we will take the current that is from the larger loop. So if we consider the larger square loop with side L, then if it is carrying current I, then magnetic field produced at the center of this particular large square loop that is given by B equal to mu 0 I upon 4 pi r into sine theta 1 plus sine theta 2. In theory, we straight this thing. This is the magnetic field produced by one side of the loop. And square loop have 4 sides. So multiply by 4. And this one is the square loop. Therefore, the angle subtended by any side of the loop at the center, this theta 1 and theta 2, will be 45. Here r that is the perpendicular distance of the center of the square loop from the side, and that will be capital L by 2. So substitute the values here. B equal to 4 into mu 0 I upon 4 pi r that is L by 2 sine 45 plus sine 45. So this is 1 upon root 2 plus 1 upon root 2. So 2 times 1 upon root 2. So it will be root 2. Take these 2 in numerator. So we will get B that is equal to 4 into mu 0 I upon 4 pi L into 2 root 2. Clear? Now, flux associated with the smaller loop, because smaller loop is placed at the center of this larger one. So that is B into A. And if we divide it by current through the larger one, we will get the mutual inductance. So mutual inductance that is 5 upon I, phi, that is the flux associated with the smaller one. Now smaller one that is with area L square, and magnetic field associated with the smaller loop that is this calculated one, 4 into 2, 8 mu 0 I upon 4 pi. Now capital L that is given to you equal to small l square. So here it is substituted into area of the small loop that is L square upon I. Now L square cancel, I cancel, and mu 0 upon 4 pi, that we can substitute 10 raised to minus 7. So our answer of mutual inductance that is 8 root 2 into 10 raised to minus 7. Take this 8 inside this root. So we will get under root 128 into 10 raised to minus 7 Henry. Now compare this value of the mutual inductance obtained here with the given value root x into 10 raised to minus 7. So we can say this thing. the value of x that is equal to 128. So our answer that is 128. Clear to all of